जो यहाँ से अब स्टार्ट करें एडिशन पॉलीमर्स, ठीक है। पीछे थोड़ी रह गया इसके बाद। सो एडिशन पॉलीमर्स था कि स्मॉल मोनोमर्स, राइट, दे वुड जॉइन अप, and when they would join up, they would all form, uh, they will link up and they will form these polymers. High temperatures, high pressures के ऊपर they would all link up at, ठीक है। Polymers are like these strands, और वो सारे strands जो है ना, they form plastics, ठीक है। They're interwoven with each other like your clothes, ठीक है। तो the first one was polythene, which is your normal plastic bags। तो उसके अंदर I told you कि ethene का molecule होता है, and all those ethene molecules, they line up and under high pressures, high temperatures, ठीक है। यहाँ पे you're going to have high temperatures and high pressures, right? तो वो सारे आपस में लिंक अप हो जाते हैं। So I'm going to do the other one now, which is polypropene। अच्छा, polypropene। अच्छा, इसमें क्या होगा कि lots of propene molecules will join up, ठीक है, and they will interlink। propene में कितने कार्बन होते हैं? It's got 3 carbon atoms, ठीक है। So propene is 1, 2 and 3, and it's got a double bond, और बाकी इसके साथ there's going to be 3 H's, ठीक है। सेकेंड वाले के साथ there's going to be 1 H, and then there's going to be 2 H's, तो प्रोपीन हो गया। अच्छा ना, अच्छा, प्रोपीन, पॉलीप्रोपीन जो है ना, दैट्स यूज्ड इन मतलब मोस्टली योर प्लास्टिक बॉटल्स, ठीक है। वो जो आपको, इट्स योर नॉर्मल प्लास्टिक पेट बॉटल्स, ठीक है। गूगल कर लेना, आई एम नॉट श्योर, मेरे ख्याल से इट्स, ऑल्दो नो वन इज गोइंग टू आस्क यू दिस, लेकिन इसको वैसे कंफर्म भी कर लेते हैं क्विकली। ठीक है, पेट बॉटल्स वगैरह कहाँ पे यूज हो रहा है, एक सेकेंड। मैं वैसे वो गूगल कर रहा हूँ, हाई केमिकल एप्लीकेशंस। अच्छा, ये जो स्विचेस हैं वो बनते हैं पॉली, ये चेयर्स वगैरह, ठीक है, मोस्ट ऑफ योर स्कूल चेयर्स आर मेड आउट ऑफ पॉलीप्रोपीन, ठीक है। वो जो प्लास्टिक चेयर्स वगैरह नहीं होती, लॉन चेयर्स एक्सेट्रा, दे आर मेड आउट ऑफ पॉलीप्रोपीन। आई डेफिनेटली नो के पेट बॉटल्स वगैरह, प्लास्टिक बॉटल्स हैं, दे आर, हाँ वो भी, चीप वाली जो प्लास्टिक बॉटल्स हैं, दे डेफिनेटली मेड आउट ऑफ पॉलीप्रोपीन। ठीक है, वो भी दिया हुआ है। अच्छा, एनीवेज, बहुत वैसी टाइम जाया करें, उस पर आ जाते हैं कि हाउ डू यू मेक अ पॉलीमर आउट ऑफ इट, ठीक है। रिमेंबर, पॉलीमर के लिए lots of monomers have to join up, ठीक है। Now the first thing that you're going to do is when you're trying to make a polymer out of it is कि ये rule याद रखो कि you have to redraw polypropene in a certain way, ठीक है। तो redraw polypropene, and how are you going to redraw it? कि make sure don't draw anything, अच्छा, anything on left or right side of your double bond। ये कार्बन डबल बॉन्ड कार्बन के ना लेफ्ट राइट पे ना, डोंट ड्रॉ एनीथिंग, ठीक है। Anything that's on the left or right side, ठीक है। Either what you're going to do is you're going to जैसा H है ना, राइट साइड पे आ रहा है, इसको बेंड करके ना नीचे की तरफ ले आओ, ठीक है। the CH3 on the left side, ठीक है, what you're going to do is bend it, तोड़ना नहीं है, ठीक है, because you're not going to draw a different molecule, you're going to draw the same molecule। You're just drawing it in a different way। एक सेकेंड। अच्छा, what you're doing is you're just drawing it in a different way। तो ये जो डबल बॉन्ड है ना, इसके ऊपर एज था और यहाँ पे एज था, ठीक है। सो ऑन दिस डबल बॉन्ड दिस एज which should be on the right side, उसको बेंड करके ना नीचे की तरफ ले जाओ, ठीक है. So remember, I haven't changed it. I've just sort of bent it, ठीक है. और इसके लेफ्ट साइड पे there's this entire CH3, ठीक है. इसको this should not be on the left side, ठीक है. It should be, इसको भी बेंड करके ना bring it downwards, उसको इकट्ठा करके लिख देते हैं CH. ठीक. तो ये clear है? Is this clear? The first part कि what I've drawn is I've I've kind of redrawn it, ठीक है. Is that clear?
Yes, sir.
अच्छा, and then what's going to happen is कि फिर it's very easy to draw the polymer, ठीक है. You are just going to draw many repeat units, ठीक है. तो that's another one. Here's another propene, ठीक है. Poly means many, so thousands of अभी चार काफी है, ठीक है. So thousands of propene molecules will come together, and under high pressures and high temperatures, ठीक है, all of them will start combining with each other, ठीक है. So under high pressures, high temperatures, यहाँ पे लिख भी देते हैं, high pressures plus high temperatures, ठीक है, they will all combine. और सबसे पहले क्या होगा, the double bond. Remember alkenes, whenever they react, it's the double bond that react, ठीक है. इसलिए वो double bond की ना right side और left side open रखनी थी. It's the double bond that's going to react, and they will start interlinking with each other. और ये आगे ही चल रहा होगा, इधर आगे चल रहा होगा. Make sure you never forget to draw the continuation bonds. वो show कर रहा है कि but this chain is still going on, ठीक है. The process is still going on. Do you clear? Is this clear? This is how polypropylene would look like. ठीक है.
Yes, sir.
महीम clear है? दुआ clear?
Yes, sir.
अच्छा, this is how polypropylene would look like. और बाकी है कि but that's it. There's going to be a repeat unit. There's another representation of it, which is कि since this thing is repeating over and over again, so another way to write this is कि you just draw one of them. और उसके इर्द ना put a bracket and put n over here, which means that it repeats n number of times, ठीक है. So that is your single repeat unit, ठीक है. That's another way of representing this polymer. अच्छा, एक और इसी तरह कर लेते हैं कि I have, ठीक है. So let's do, अच्छा, now let's try and do another one, which is poly butene, ठीक है. तो poly, अच्छा, so what's polybutene? So it's going to be made out of butene, ठीक है. So that's the first thing. ब्यूट पे कितने कार्बन्स होते हैं? क्या होता है? How many carbons do you have in bute? Anyone? भैया मिलेगा क्या होगा? दुआ क्या होगा?
Sir, 3 or 4?
4 होते हैं, ठीक है. Remember, meth is 1, eth is 2, prop is 3, and bute is 4. तो एक तो ये it's going to have 4 carbon atoms, ठीक है. Alkene है तो उसका मतलब it's going to have a double bond, ठीक है. और 2 के ऊपर second वाले पे double bond, ठीक है. 2 ene. And you can draw the H's. This carbon needs 3 more bonds, so there's going to be 3 H's. हर carbon के 4 bonds होने चाहिए. This one would probably need 1. This one would need 3 H's, ठीक है, to complete the 4 bonds. Now again the same thing. First thing, you have to redraw this. ये जो double bonds है ना, the right and left side should be open. तो आप क्या करोगे, व्हाट यू गोना डू इज के इस डबल बॉन्ड के राइट साइड पे जो भी है ना, यू गोना बेंड इट एंड यू गोना पुश इट डाउनवर्ड्स, और उसके लेफ्ट साइड पे जो भी है यू गोना जस्ट बेंड इट एंड पुश इट डाउनवर्ड्स, ठीक है। तो दैट्स व्हाट सो यू गोना रीड्रॉ दिस, ठीक है, और रीड्रॉ कर लेते हैं। सो आई एम गोइंग टू हैव अ डबल बॉन्ड विद टू एचेस ऑन टॉप, लेकिन ये जो राइट साइड पे सी एच थ्री है ना, दिस सी एच थ्री ओवर है, दैट शुड नॉट बी ऑन द राइट साइड, उसको बेंड करके ना नीचे ले जाएंगे, ठीक है। तो दिस सी एच थ्री इज बेंड डाउनवर्ड्स, और लेफ्ट साइड पे जो सी एच थ्री आई एम गोइंग टू बेंड इट। तो ये दोनों सी एच थ्री जो है ना, राइट और लेफ्ट पे, I've sort of pointed them downwards. Is this clear?
Yes, sir.
ये क्लियर है। और फिर आसान काम है कि इसी ने ठीक है, thousands hundreds of thousands of monomers, they'll all line up, or high pressures, high temperatures के ऊपर, they will all join up, ठीक है। सारों के बीच वाले जो डबल बॉन्ड्स है ना, they will turn into single bonds. The double bonds are going to react and they'll start interlinking, ठीक है। This one would link with this one, all of them are interlinking with each other, ठीक है। And that's your polybutene molecule, ठीक है। And you can also try and draw a single repeat unit, और ये उसके ना ब्रैकेट डालो NN, ठीक है। Is this clear? So this is your polybutene polymer. ये clear है ना सारा कि how to sort of redraw this when you're trying to make the polymer. ये clear है?
Yes, sir. Yes, sir.
अच्छा, अब ये कि इसके there's certain examples that you have to remember. One of them is PVC, ठीक है, that's polyvinyl chloride. ठीक है, this is a very important polymer. It's a polymer that's used. It's a very popular polymer, ठीक है। Remember, अब हर चीज ना, everything kind of your doors, मतलब जितना your floors, your windows, ठीक है, कार के अंदर जितना भी वो um, but there was a time when cars had wooden dashboards, ठीक है, and wooden panels. तो वो सब चीजें ना, everything is now made out of plastics, ठीक है। Your laptops are made out of plastic. तो even आपकी स्कूल की चेयर्स वगैरह, desks, buildings, most of the stuff that looks like wood, that's not actually wood, that's just plastics, ठीक है। आपकी घर की किचन की cabinets जो है ना, they're actually made out of plastics. They're not, no one uses wood or iron or steel anymore, or aluminium, ठीक है। अच्छा, तो PVC is a very popular polymer, ठीक है। That's तो ये आपकी जो वुडन टाइल्स वगैरह सारी जितनी भी आपको नजर आ रही थी ना, लाइक स्पेशली द आर्टिफिशियल वुडन टाइल्स, योर किचन कैबिनेट्स, योर पाइप्स एक्सेट्रा, ठीक है। तो नाउ most of the doors in new buildings and the windows in new buildings are made out of PVC, ठीक है। तो it's frequently used for flooring as well, ठीक है। So you make a lot of stuff out of it. अच्छा, what is PVC? PVC is just like वो ethene जैसे ही है। The only thing is that the monomer is chloroethene. It's got one Cl. That's it. और जो chloroethene monomer है, what is that going to do? It's going to form the polymer, ठीक है, the polymer chain. It's going to form the polymer chain, and they will all link up with each other. Okay, that's it. That's your PVC molecule. Okay. Then so we'll see other thing. It's like polyethylene, but with the Cl in it. Our next one is that's PTFE. वो जो है ना, that's Teflon. PTFE is its name is polytetrafluorocarbon. यानी इसका जो मोनोमर होता है ना, that's made out of tetrafluoro. That means 4 fluorines and ethene with 4 fluorines, and that's my monomer. ठीक है, so उस तरह के ढेर सारे monomers, they will line up and they will eventually form the polymer. The double bonds will react and they will all interlink. ठीक है, each of these carbon is short of a bond. So that's what PTFE would look like. PTFE use कहाँ पे होता है? It's used in कहाँ पे use होता है? It's used in it's non-stick that's used in cooking utensils. तो वहाँ पे ना जो black substance होता है, like if you have a frying pan and it's got the non-stick frying pans have a green coating, a black coating on top of it. ठीक है, तो that's what PTFE is. ठीक है, that's what Teflon is. तो ये आपने याद रखना है. तो ये हमारा वो alkenes खत्म हो गया. इसके बस अपना थोड़े से फायदे नुकसान. ठीक है, some advantages, disadvantages. तो especially addition polymers. Now the first thing is advantages of your normal addition polymers. So the advantages are that they are very unreactive. So which is why they are long lasting. If you make a kitchen cabinet out of PVC, then that kitchen cabinet, मैं दिखा भी देता हूँ ऐसे एक सेकंड. These things, kitchen cabinets, they're all made out of plastics. ठीक है, जितनी भी modern kitchen cabinets are all made out of, they're all made out of plastics. ठीक है, even windows etc. they're all made out of PVC plastic. ठीक है. अच्छा, so advantage is they're very unreactive, very long lasting. ठीक है, so and they're very strong as well. And orchid advantage is a bit cheap as well. ठीक है. You've got plenty of raw material. Where do you get all these alkenes? You get them from petroleum. ठीक है. As a disadvantage of having addition polymers. Now the disadvantages are many. They're also not soluble. Most of them are not soluble. ठीक है. The plastics होते हैं, they are kind of waterproof as well. So now the disadvantage is, because of this one reactive, number one, they're non-biodegradable. And once you produce them, they're going to stay in the environment for a very, very long time. Okay? They don't decompose naturally. So they stay in the environment for hundreds of years. Okay? So, but now there's a thing called microplastics, which means uh, like if you have a Nestle bottle made out of plastic, so over time what will happen is that it will break down, okay? But it will break down into, but like though it won't break down if you just bury it, it's nothing would happen to it. But over time, if it gets used a lot, it will crack and break down into smaller pieces. Those smaller pieces will break down into further smaller pieces, and then they will turn into microplastics, like small particles of plastics, which enter your food chain, and you are constantly consuming them. So they're non-biodegradable, and that causes a lot of problems. ठीक है? और क्या होगा कि burning them, you can burn them, but that causes pollution. ठीक है? So that's not a good way as well. ठीक है? Lots of greenhouse gases are going to get produced अगर आप इसको burn करोगे. अच्छा, the third thing is that animals could choke and die on it. ठीक है? Atlantic के अंदर ना there's this huge area that's the size of countries that is full of plastics. They've got, I mean, it's like an island made out of plastics. So your oceans are getting polluted. ठीक है? अच्छा, so how do we get rid of all these problems? ठीक है? The first thing is recycling, or use alternate. Any Nestle bottles, they need to be recycled, ठीक है? Or use, but recycling has its limitations because you have to collect all the empty bottles. Plus, the bottle can only be recycled a number of times, a limited number of times. After which, the plastic will deteriorate so much that it would be very hard to recycle. Or the other thing is you can use alternative uh, alternatives, like example, uh, a glass bottle. Yeah, you're buying stuff, right? So don't use plastic bags, paper bags instead. Essentially, is this all clear?
Yes,
Yes,
sir.
sir.
तो बस यहाँ तक हमने कर लिया, अब उसके क्वेश्चंस कर लेते हैं. So we just left LM and O. So we just left with the last part. What's up? Yes. Too long for it to open.
सर सारे पॉलीमर्स के वही
अच्छा उतनी
एडवांटेजेस
देर
और
you can
डिसएडवांटेजेस है ना, जितने भी पॉलीमर्स हमने
हाँ
पढ़े हैं?
सारों के
ओके
हाँ और सारे एडिशन ये एडिशन वैसे मोस्टली दिस इज अबाउट एडिशन पॉलीमर्स ठीक है जो हमने पढ़े हैं ठीक है जैसे आपके कपड़े बनते हैं पॉलिएस्टर्स दैट्स आल्सो अ पॉलीमर बट दैट्स नॉट एन एडिशन पॉलीमर वी गोना स्टडी दैट लेटर ऑन वो डिकम्पोज हो जाता है but you've never seen dustbins full of clothes but where do all the clothes go they just biodegrade very very naturally ठीक है वो छोटे छोटे पीसेस में टूट के they just disappear or they mix in the environment ठीक है लेकिन
तो
प्लास्टिक
सर
बॉटल्स जो है अभी हमने
तो
सिर्फ
सर मतलब अभी
एडिशन
हमने
अभी
लाइक यस यस कंटिन्यू।
अभी हमने सिर्फ एल्कीन्स का किया ठीक है क्लियर है
यस सर क्लियर हो गया।
हाँ तो वो मैं वर्कशीट भेज दूंगा वो इट्स नॉट डाउनलोडिंग एट द मोमेंट लेकिन ये कर लेते हैं अल्कोहल स्टार्ट कर लेते हैं ठीक है तो एल्कीन्स जस्ट अ क्विक रिकैप ठीक है एल्कीन्स का क्या था दे हैड लॉट्स ऑफ एडिशन रिएक्शंस ठीक है एल्कीन्स का ये था कि wherever they see a wherever you see a double bond some molecule is going to get attached to the double bond ठीक है and it will turn into a single bond bromination was one double bond नजर है bromine cut itself attached or bonded to carbons यहाँ पे भी you had the double bonds and the bromine molecules they came and they got attached to the double bonds ठीक है hydrogenation था which was double bond hydrogen is going to get attached to the double bond it will form an alkane an unsaturated molecule would turn into a saturated alkane hydrogenation का जो पर्पस था वो था कि मार्जिन फॉर्मेशन में कि alkene का मॉलिक्यूल होता है and double bond में H's get added so it turns into a saturated molecule which is margarine हाइड्रेशन में वाटर ऐड होता था HNOH है तो wherever there was a double bond H and OH will get added और फिर एक हाइड्रोजन हैलाइड था which was HCl would also get added to the double bond so double bonds are very reactive ठीक है और ये भी डबल बॉन्ड के रिएक्शन that it's double bonds that are interlinking with each other ठीक है अच्छा अब ये कि alcohols first thing what's an alcohol is something that's got an OH group right so the general formula of an alcohol is CnH2n plus 1 OH ठीक है is clear अब alcohols में कि for example if I have ethanol the two carbon atoms and it's going to have OH so this molecule is going to be called ethanol ठीक है we already did naming अच्छा if I have butanol तो somewhere on these carbon atoms there's going to be an OH so you have to be specific this is butan 2-ol the second from the right it's got OH groups attached to it so this one is butan but 2-ol because the OH is attached on the second carbon atom ठीक है तो ये alcohols था and CnH2n plus 1 like if you have C4 H क्या होगा double plus 1 so that's going to be 9 and OH so that's ये ऊपर वाला molecule है that's exactly this C4H9OH ठीक है is this clear general formula और ये structure clear है
यस
Yes,
सर।
sir.
अच्छा starting with the physical properties first now the physical properties are very different from well not entirely different वो बस एक difference है कि they're going to have higher melting and boiling points second difference is that they have they're very soluble in water as well ठीक है, these are two properties, and this is compared to alkanes and alkenes. ठीक है, ठीक है, is this clear?
Yes, sir.
Or so compared to alkanes, alkenes. अच्छा, then the reactions. पहले the formation of alcohols. ठीक है, that's इसमें सबसे important ये. अच्छा, now alcohols are very very important industrially. ठीक है, alcohols का ये कि it's after water, it's the main industrial solvent. ठीक है, और उसका ये भी है कि यहाँ पर मैं लिख दूँ एक सेकंड. अच्छा, so it's used as a solvent. जैसा नेल पॉलिश, मतलब नेल पॉलिश रिमूवर्स तो अल्कोहल्स आई थिंक नहीं होते, या होते हैं शायद. एक सेकंड, लेट मी जस्ट चेक. नहीं होते. Alcohols can be used, I mean, they are used as nail polish removers as well. Hand sanitizers वगैरह. ठीक है, uh, तो एंटीसेप्टिक प्रॉपर्टीज होती हैं. ठीक है, एंटीबैक्टीरियल, सो इट्स यूज फॉर सैनिटाइजिंग. तो इन मेडिसिन में यूज होता है. ठीक है, अच्छा, इट्स यूज एज अ फ्यूल एज वेल. बहुत सारे कंट्रीज में, फॉर एग्जांपल ब्राजील के अंदर ना, अल्कोहल इज मिक्स्ड विद पेट्रोल. अच्छा, और क्या इसके यूज है कि उसमें मेडिसिन बनाने में, फॉर एग्जांपल पेनाडोल एक्सेट्रा. ठीक है, एनीथिंग दैट्स गॉट ऑल इन इट, it's very highly likely that they have alcohol in it. ठीक है, तो ये सारे इसके पर्पसेस हैं. अच्छा, सो इसकी जो फॉर्मेशन ऑफ अल्कोहल्स है, नंबर वन वी ऑलरेडी डिड. दैट वाज हाइड्रेशन ऑफ एल्कीन्स. ठीक है, वी ऑलरेडी डिड दैट. कैल्कीन नजर आए, उसमें वाटर ऐड कर दो. ठीक है, तो दैट वाज हाइड्रेशन ऑफ अल्कोहल्स. नंबर टू जो है, नंबर टू इज द वन दैट्स मोर इम्पोर्टेंट. दैट इज फर्मेंटेशन. जो बड़े बड़े सेलर्स वगैरह होते हैं, ठीक है, वेयर अल्कोहल इज ब्रूड. ठीक है, so that is fermentation. That's where alcohol is made at large scale. Fermentation का भी खैर डिटेल ज़्यादा तो नहीं अभी कर सकते, लेकिन the basic reaction is, and the conditions is that they take glucose. That glucose can be extracted from any any cereal or any fruit. ठीक है, you can extract glucose, and that glucose is then turned into ethanol, which is C2H5OH. Plus carbon dioxide gas is given off. The reaction conditions are that it has to be anaerobic, which means without oxygen. So sealed airtight containers के अंदर ना, the glucose is stored, and the glucose is allowed to ferment. You add yeast, which is a biological catalyst. Your yeast is like a fungus, which releases an enzyme which is going to add. So yeast basically speeds up the reaction. So it is a catalyst, and the temperature has to be around between 22 35 degrees centigrade. So you don't want either a very cold or a very warm environment. A higher or lower temperature would kill the yeast. So denature का मतलब है denatures or makes the yeast inactive. So ये reaction आपको ना याद रखना है, and you have to remember these conditions. It has to be without oxygen. Without oxygen, मैंने with लिखा है. It has to be without oxygen. Yeast as a catalyst is used, and temperature has to be between 20 and 35. So eventually the alcohol will be produced. Lekin it's going to have very low yield, extremely low yield. But 10% is ज़्यादा नहीं पता. Very low yield. Why? Because remember alcohol जो था, it's used in hand sanitizers. So what alcohol does is it kills the yeast. Okay, so it kills the yeast, which is why alcohol जैसे ही produce होता है ना, the reaction stops. So after a certain point, after almost like a few molecules of alcohol getting produced, the reaction almost completely stops. So ये clear reaction ये वाला fermentation.
Yes, sir.
Yes.
तो चलो ठीक है, यहाँ से ना हम फिर कंटिन्यू करते हैं, ऑर्गेनिक को ना खत्म करने की कोशिश करते हैं. ठीक है, इस वीक. चलिए, ओके, एवरीवन टेक केयर.
Allah Hafiz, sir.
Allah Hafiz, sir.